second order differential equations. So they look like this.
Uh-huh.
Or I don't know if you've seen something like this, d2y over dx square. Okay, plus,
Mm-hmm.
let's say this is multiplied by a, and then b times dy over dx plus
Mm-hmm.
c times your y equals 0. So there is a function y. You will see its first order derivative. This is first order derivative. This is second order derivative. It basically means that you have taken the derivative two times,
Right.
right? And it's usually written like this: a times y double dash plus b times y dash plus cy equals 0. Okay,
Mm-hmm.
and now we need to know how can we find out the solution of a second order differential equation. Okay, so what I will first explain you what will be the meaning of such a differential solution of a second order differential equation.
Mm-hmm.
Okay, wait a second. Let's say that you have a differential equation like this: y double
Mm-hmm.
dash minus 9y equals 0. Okay, I'm talking
Mm-hmm.
about if you want to find out the solution of this equation.
Right.
That means you need to find out a function y, okay, a function y whose double derivative is equal to 9 times that function, right? Can you think of such a function whose double derivative is equal to 9 times the function itself?
Do you mind scrolling up a little bit just so I can see the whole thing
Yeah.
for reference? So I need to find something that gives me y prime, y double prime equals 9y.
Yeah, just concentrate on this one. Can you find out a function?
Would it be, wait one sec. Would it be, so I need to find what y is, right?
Mm-hmm.
Is that what it is? Would I divide y on both sides?
No, 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 nothing, no calculation. Just try to think which function, if you take its derivative and then you take its double derivative, then that,
Oh, of 9.
yeah. So,
So you get 9 over 2 y squared, that's your first.
no, no, no. So, for example, think about it. If I have a function y equals e to the power 3x, okay?
Mm-hmm.
If I take its first derivative, it is 3 times e to the power 3x, right?
Correct.
And if I take its second derivative, that's going to
Mm-hmm.
be 9 times e to the power 3x, right? And
Uh-huh.
this e to the power 3x is nothing but y, right?
Okay.
So my double derivative of y is equal to 9 times y, right?
I see what you're
Or
saying.
double derivative of y minus 9y gives me 0. So one solution to this differential equation would be y equals e to the power 3x. That's, I can say that this is the solution.
Mm-hmm.
This is the solution to this equation, right?
Oh, I
Similarly,
see what you're saying.
yeah. Similarly, you can actually take any constant multiple of this function. Any
Right.
constant multiple. So, for example, if I take y equals, let's say, 5 times e to the power 3x, would you say
Right.
that this will be also the solution of this differential equation?
Yeah.
Yeah, because if we take first derivative, we are getting um,
15e to the 3x.
15e to the 3x, and if I take the second derivative, then I'm getting 45e to the,
45e to the 3x.
which is 9 times
5.
y, the original function, right?
Yeah.
So it does not matter which constant you are taking, this 5, you can take any constant, okay? So
Hmm.
any constant, 5, -4, 100, 1000. So basically, any function of the form, I'm writing one very important thing, any function of the form c1
Hmm.
times e to the power 3x, can I say all such functions will be solutions of this equation,
Yes, it can.
where c1 can be any integer?
Yes.
Okay, all right. So now we will extend this observation to find out the solution of this equation, this one. Okay, let me go
Okay.
to the next page. Now what happens is, when you have an equation, second order equation, y a times double derivative of y plus b times y dash plus your c times y equals 0, we say that we suggest a solution that y equals
Right.
e to the power r t. Now in second order homogeneous solutions, we usually use the variable t instead of x. So far we have been saying that y is a function of x. Now in case of second order homogeneous solutions, we say that y is a function of t. The reason is because this concept is used, most of the cases it is used in the problems in which y is a function of time. Okay, this is mostly
Got it.
used in physics, so we take y as a function of time. Okay, so
Got it.
the independent variable we take as t.
Got it.
Okay, so we suggest that y equals e to the power rt is one solution. Then what will be the first derivative of y? It's gonna be r times e to the power rt. What will be the second order derivative? It's gonna be r square times e to the power rt. Now what we will do is we will substitute these values in this equation. Let's substitute. So we get a times r square e to the power rt plus b times y dash is r times e to the power rt
Right.
plus c times e to the power rt equals 0. Now we'll try to solve this. We'll try to solve this for r.
So AR squared,
E to the
your
power rt can be factored out.
mhm,
E to the power rt, e to the power rt, e to the power rt. We factor it out, so we get a times r square plus
plus BR plus
br
C.
plus c equals 0. Now
Mm-hmm.
we'll use the zero product property. This e to the power
Oh,
rt is not equal to 0.
right.
This is not equal to 0,
Right.
because that would mean that your y is equal to 0 is the solution, but that's not the case. So that means this has to be equal to 0.
Right.
So we say that a times ar square plus br plus c is equal to 0, and this is
Hmm.
a simple quadratic that we can solve.
Oh, great. Quadratics. Um, I guess you could do the quadratic formula. I don't know.
Yeah, so you don't need to solve it. We will do a practice problem now. You'll understand how to use this entire thing in the questions.
Let's do it.
Yeah, okay. So let's say we have you noted this down?
I've noted everything.
Okay, I'm gonna write the problem right here so that you can compare everything. So we have a second order homogeneous. Okay, I also wanted to explain you what homogeneous means.
Homogeneous, I guess it's a means the same, right?
No.
Basically.
Homogeneous, and we will also do non-homogeneous. So when this expression on the left hand side, this is all equal to 0, this means it's a homogeneous differential equation. Okay, but instead of 0, if you have something else, like if you have a variable x or something else, then it's a non-homogeneous differential equation. Okay, so
All right.
there are three terms. We say it is first order, no, not first order, second order this time. So we say it's a second order linear second order homogeneous differential equation. So you should know
Um,
the meaning of these three terms. Linear means that all of these derivatives have power 1,
right.
right? This is power 1. And second order means that the highest order of the derivative is 2.
Mm-hmm.
And homogeneous means that on the right hand side you will have 0. Okay, let's do this. So we have this equation. First, what are the values of a, b, and c?
Okay, so the values of A, isn't A just 1?
Yeah, a is 1, b is 11,
And then C is just 24.
c is 24.
So we
So,
write this in quadratic form?
yes, we will write this quadratic equation. ar square plus br plus c.
Okay.
So we get r square plus 11r plus 24 equals 0. And from here we will solve for r. Can you solve for r?
Yeah, let me do that fast.
Uh,
You really like giving big numbers. Alrighty, so I got negative 11 plus or minus 5 over 2, which gives me negative 11 plus 5 is negative 6 divided by 2 is negative 3, or negative 16 divided by 2 equals negative 8.
so
Those
what
are my
are the two
answers.
values?
Negative 3 and negative 8.
Negative 3 and negative 8, yes. Wait, I also need to give you initial value for this. Y of 0 is 0
Right?
and y dash 0 is equal to negative 7. Okay, we'll use
Got
that
it.
later. So we have got r1. So we are getting two values of r, negative 3
Mm-hmm.
and negative 8. So my solution, I'll get two solutions. See, the solution is this. This was the solution, right? Y equals e to the power rt. This is the
Right.
solution. So now I have two values of r. So we say
Uh-huh.
that r1 is negative 3 and r2 is negative 8. This is r2.
Got it.
So I have two solutions. Y1 is equal to c1 times e to the power negative 3t,
And
and
then
second
y2
c2,
equals negative e to the power negative 18.
yes. So these are two solutions, and now there is a theorem that I should have told you here. If you have two solutions like this, Then if you add them, for example, this was one solution, y equals 5 times e to the power 3x, and other solution was y equals e to the power 3x.
Mm-hmm.
So if I add them, so 5 times e to the power 3x plus 9 times e to the power 3x, this will also be the solution.
Oh,
Okay, you can check that.
cool.
You can actually find out y double dash and substitute the values. This will also be the solution. So
Got it.
over here, my final other solution will be yt
Mm.
is equal to c1 times e to the power negative 3t plus c2 times e to the power negative 8t. This is
Mm-hmm.
the general solution.
Got it.
Okay, this is your general solution.
It seems a lot easier than first order. I think I understand why my teacher likes second order.
Yeah, second order is much easier. It's a straightaway approach. Okay, this is your
So
general
that's
solution, but you need to find out the specific solution by using this initial condition. Okay,
all right.
so just put t is equal to 0 and y is equal to 0.
Got it. So
So
then
we'll get 0 is equal to c1.
e to the power of negative 3 times 0, which is just c1 itself,
Mm-hmm.
plus c2 times e to the power of negative 8 times 0, which is, so you get 0 equals c1 plus c2.
Yep, that means that c1 is equal to negative c2. That's your first equation. Second
Mm-hmm.
equation you can get from the second initial condition. Y dash 0 is also given to us.
Y dash 0 equals,
Negative 7. So first you need to
right,
find out what will be y dash of t. That's going to be negative 3 c1 e to the power negative 3t minus
plus, oh, minus.
8c2 e raised to negative 8t, and now we put t equals 0 and this thing as negative 7. So this will give us negative 3c1 minus 8c2. So now we have two equations.
Mm-hmm. Negative 7 equals negative 3c1 minus 8c2.
Yeah, so you can substitute c1 equals negative c2.
So negative 7 equals negative, wait,
So
okay.
you put c1 equals negative c2, so this becomes positive 3c2 minus 8c2, which is
Which
negative
negative,
5c2. So c2 equals 7 over 5 and c1 equals negative 7 over 5.
wow.
So your final solution is yt equals negative 7 over 5 times e to the power negative 3t plus 7 over 5 e raised to negative 8t.
Got it. Wow, that's really easy.
Yeah,